With the aid of high-speed photography, we can see a projection weld as it takes place. A resistance weld is the result of steel components under pressure for a controlled period of time with current flowing, creating sufficient heat, causing the metals to coalesce. When current ceases to flow and the area begins to cool, you have created a permanent bond. The basic factors for a resistance weld to take place are heat, time, and pressure. When these factors are in proper balance, an optimum weld will follow. This applies to both spot and projection welding. Properly installed Ohio weld fasteners will provide an excellent attachment method without the need for secondary operations. Typical weld setups for Ohio parts welded to C1010 low-carbon cold-rolled sheets in a thickness range of 0.025 to 0.187 can be found in the weld data section of the standard Ohio weld fastener catalog. We have used these setup guidelines in all of our examples that will follow. We begin our weld demonstration with Ohio parts designed for spot welding. The first example is our XN style weld nut. The XN's narrow body enables it to be welded in corners and confined areas. The XN has a precision locating pilot, full threads, and is countersunk for easy entry of a mating part. As with all spot welding, the diameters of the electrode tips are extremely important as they control the size of the weld area. The basic spot weld technique of using a smaller diameter electrode tip on the thicker part and a larger diameter tip on the thinner material side is being used. On the 1/4 20 and smaller XN sizes, there is a target area of reduced thickness. This creates a more favorable balance of material thickness when the XN is welded to lighter stock. Our SS-style spot weld spade screw has an ideally shaped flat spade at right angles to the threads. The spade permits welding to or through metal surfaces. The spade has been designed to be used with various sizes of electrode tips. It is designed to fit in confined areas, such as narrow channels, walled corners, and in those applications requiring threads offset from component surfaces. Again, the smaller diameter electrode will be on the thicker material, in this case the spade of the SS weld screw. The final spot weld example will be an Ohio TP, a twin-piloted spot weld nut. Use of the Ohio TP nut eliminates the need for two individual nuts. It also strengthens the assembly and in some cases helps align parts. The twin pilot's full threads can increase the clamping pressure available over the single weld nut assemblies. We offer a large variety of spot weld nuts, screws, and pins to fit most application needs. Projection welding, the weld area is controlled by the size and shape of a preformed weld projection. On Ohio parts, these precisely designed and located projections cause the current or heat to be concentrated as it flows between the fastener and the parent material. Welding occurs as the projections fuse or coalesce with the surface of the component part. It is recommended that all projection welding be done on a press-type welder. This type of welder has an air cylinder or hydraulic cylinder directly over the electrodes. Its travel is in a straight line. It is important to have good alignment and equalized pressure at the electrodes. Electronic controls to maintain the proper relationship of heat, time, and pressure are important to achieving optimum welds. Proper heat balance is attained when the fastener and the component part are brought to the welding temperature simultaneously. In resistance welding, time is expressed in cycles. One cycle represents 1/60th of a second. Total time is divided into three categories: squeeze time, weld time, and hold time. In projection welding, when excessive electrode pressure is applied, the resistance between the part and the material being welded is decreased, causing weak, incomplete, or no welds at all. Insufficient pressure can cause flashing, burning, and discoloration. Control of these factors, heat, time, and pressure will ensure quality results in projection welding. The electrodes for projection welding must be large enough to cover the entire fastener to be welded. Therefore, these electrodes are usually flat with large diameters. The more bearing surface that can be obtained, the greater the electrode life. In longer production schedules, a 1/4 inch thick pad of RWMA Class 12 copper alloy brazed to the surface of a regular electrode is recommended. We offer this feature on our Ohio insulated electrodes, designed for Ohio through-hole screws or pins. A beneficial feature of projection welding is the smooth and clean appearance this process provides. In many applications, the weld assembly is ready for paint or plating. Another feature of projection welding is greater strength. The projection weld fastener can be welded to thicker material, obtaining greater penetration into the parent metal than can be achieved with spot welding. As you can see with projection welding, a wide range of material thickness can be accommodated. When using a ring projection like the one on our WW projection weld nut, the weld not only permanently attaches the part, but hermetically seals the WW nut. The ring can increase the weld strength in thinner material applications. Our first example of projection welding will be our GW-style weld screw. The GW has 3 uniform projections on top of the head for welding to the surface of a component, eliminating the need for a hole to locate the screw. As you can see, there is minimal marking on the reverse side of the sheet. In a pull test, weld nuggets are pulled from the sheet. The large head diameter and 3 weld projections make the WF flange nut a strong nut to which other components may be attached. The long body of the WF may also serve as a bearing point, a mounting surface, or as a spacer. In a push test, weld nuggets will be pulled from the sheet. Our WS 3301 3/8 16 square projection weld nut has 4 uniform pyramid projections that provide proper seating and positive welds. Thread engagement is enhanced by a countersink on each side for easy engagement. In a direct push test, the WS will pull weld nuggets from the sheet material. Ohio's HW-style weld screw has 3 equal-size projections on a generous size head. Through-the-hole use allows self-location and eliminates any other fixturing. When threads extend through the sheet, an insulated lower electrode is essential. It will prevent the current from passing through the threaded portion of the fastener, resulting in current loss and damage to the thread. We are using an Ohio insulated lower electrode. As you will notice, there is very little marking on the underside of the test plate. In the destruct test, using a direct push against the welds, we will push slugs from the sheet. The heavy-duty RH flange weld nut has 3 projections under the head and is designed for through-the-sheet locating. Because of the projection's generous size, the part can weld to a variety of material thicknesses. The long body provides extra thread engagement and a bearing surface, or a structural support. When welding this type of part, an insulated lower electrode is recommended. Even to the 14-gauge material, there is little discoloration or heat marking on the underside of the weld. By using a direct push test, slugs are pushed from the sheet.